Hi, it's Group 13 again, and today we'll talk to you about the sequence diagrams. Let's again start by seeing where they are in the UML hierarchy. We can find them under behavioral diagrams, just like the use case diagrams we saw last week. Sequence diagrams are used to show how and in which order different objects work together. Often a diagram is related with one certain use case. Each diagram has two dimensions: the horizontal axis, which represents the object dimension, and the vertical axis represents the time dimension. Objects are usually arranged from left to right, depending on the order in which they take part in the message sequence, and the time progresses from the upper edge of the diagram downwards, so the latest events are always at the bottom of the diagram. Let's take a look at the different parts of the diagram. First of all, lifelines. One lifeline represents one participant in the system, and it can be indicated by a few different symbols. The ones you'll probably encounter the most are the ones with simple rectangles with the participants' names underlined, and the ones with actor symbols. Note that an actor is not necessarily one physical entity, but rather a specific role of some entity. In addition, lifelines can also represent boundaries, control, or entities. Next up, messages. There are quite a few different kinds of them, but luckily they're all quite self-explanatory. We have synchronous messages, in which case the sender always waits for the receiver's response before continuing, and we have asynchronous messages that do not require a response from the receiver in order for the sender to continue its work. Since a response is always needed in the case of a synchronous message, then marking the return messages on the diagram is optional. In addition, we have creation and destruction messages that clearly create or destroy different lifelines. Here you can see an example of that. We can see that object 3 is created later in time by object 1, and in the end both objects 2 and 3 are deleted by object 1. We can also have reflexive messages, which imply either a recursion or one method calling another method of the same object. Sometimes messages might either get lost or appear from unfamiliar sources in context of the current diagram. Usually, in this case, the messages are exchanged with something that has not been modeled in this diagram. Typically, we model messages by horizontal lines, but in case of real-time or time-bound systems, we might also want to stress the duration of the message. In order to do that, we use sloping lines. Remember that vertical axis represents time, so moving down in the diagram means going forward in time. We can also model a bit more complex concepts, such as if-else clauses and loops. In the example on the slide, you can see that if a card is entered into an ATM machine, then the machine can either ask for a password or state that the card is invalid. Loops are modeled in a similar way. We draw a box with the keyword loop and the loop condition given at the top left corner. The final part of the diagram that we'll need to know are the activation bars, which are also known as execution occurrences. These bars, shown as thin rectangles on the lifeline, are used to show that an object is active, completing a task, and interacting with some other object. Finally, let's have a look at a small example of a sequence diagram that models customers buying things either with cash or a credit card. We have 4 lifelines here: the customer, the cashier, the card processor, and the cash register. In the first loop, the customer gives each item he wants to buy to the cashier, who then adds up the cost of the purchase. After all items are considered, the cashier responds by requesting payment. Now we have 2 alternative scenarios depending on how the customer wants to pay. If he chooses to pay by cash, then the cash is deposited to the cash register and the change is returned to the customer. But if he chooses to pay by card, the card is processed by the card processor and the process status is returned to the cashier. In either way, if the payment was successful, the cashier gives a receipt to the customer.
I will give 2 reasons why sequence diagrams can be useful. The first reason is related to the fact that each diagram has its own strengths and weaknesses. A diagram type might have notation that makes it clumsy to convey certain types of information or lack notation altogether. Diagram types that are compatible with each other can cover each other's weaknesses. For example, a user story or use case diagram can give only a very high-level overview of something and potentially lead to some confusion due to leaving some details unspecified. Since a sequence diagram usually captures the behavior of a single scenario, similarly to user stories and use case diagrams, then these diagram types are compatible and can complement each other quite well. A sequence diagram can then be used to show what happens on a lower level during some process. This can also lead to a better understanding of system requirements and helps finding classes and associations that were not visible before. As with all diagram types, one should add elements only when they add information, otherwise it will just add clutter and be counterproductive. It helps to know the target audience or goal of a diagram, in addition to the goal of the system or process itself. One criticism of use case diagrams was that they don't support loops and conditionals, leaving potentially relevant and important information out. Sequence diagrams, however, have support for these, but also for parallel execution. There is also the possibility to make diagrams simpler by hiding complexity by bringing it under a more abstract container or through referring to other diagrams. I will borrow an example from the Unified Modeling Language Reference Manual. To create a loop, one has to have a container with the text loop in the upper left corner. Here goes the condition upon which the loop is entered and re-entered. To create a conditional branch, a container is created with the text alt in the upper left corner. The two branches, or if there are more, they are always stacked on top of one another with a dashed line separating them. On the right side, we have a condition that leads to this specific branch. And additionally, if some sequence might take too much room or too much effort or otherwise, if it is not important to know the details, but at the same time it's still useful to show where that sequence takes place in relation to other sequences, then this can be done with a reference to another sequence. This is called an interaction use node. It's a container with the text ref in the upper left corner and a short description in the middle. This hidden sequence can then be shown in another sequence diagram. There are more specialized constructs such as object creation and destruction, time constraints, messages from unknown senders, and messages that don't reach their recipient. I will not describe these in detail, but they can be looked up in the UML specification documents. To conclude, sequence diagrams fit nicely together with other diagrams and diagram types due to supporting single scenarios and abstraction. They can also be used to convey very complex processes, while also allowing some simplifications and abstractions to be made.
Sequence diagrams are also good to use in design meetings, especially when discussing like specific parts of the system, because in design the main thing you're kind of trying to figure out is how the system is gonna come together, how the whole mess of different parts and components are gonna interact with each other to make a unified system. And for that you're gonna really wanna consider all the specifics, so it's good to have a diagram that shows all the concrete behaviors and shows you in detailed way how the system works, and is really focused on the behavior of the system and leaving out all the unnecessary information, like maybe like objects and what their specific values are and all that, because you're not really focused on that in this sort of phase of development. I think also the sequence diagram might keep things a little more grounded in design meetings. Maybe if you have only abstract diagrams then the meeting might also have a tendency to stay a little more abstract and hazy in its discussion, and so the results would be like that as well, and that might lead to some results that are a little open to interpretation and might result in some misunderstandings. While if you have like a good sequence diagram in front of you, you might be more inclined to really think about how the whole thing is going to work in practice and go into a little more detail. Sequence diagrams are a great way to coordinate between different teams working on different components of the same system, if these components are going to be interacting with each other in some way, because the teams are going to need to agree ahead of time of how exactly the interaction between the components is going to work. They're going to want to know what sort of functions are going to get called and what sort of responses are expected to these calls and all that sort of stuff. And for that it's good to use a sequence diagram. Like for example, if you're making an app that's for sending emails, you might have two teams, one working on the program side of things, one working on the server side, and they're gonna wanna agree on how they're gonna do it. You might say they could use an object diagram for it, but an object diagram has a lot of information there that you do not need. Like the server people do not care what sort of how the program works internally. They only want to know the bits that are relevant to them. Only what messages are gonna come to the server and what sort of responses are expected of them. And that's what a sequence diagram shows. And as it doesn't show much else, then it's a perfect candidate for that sort of job.
One of the major advantages of a sequence diagram is that you can reference common interactions and easily specify alternative scenarios during interaction fragments. Thus, you can describe in a single sequence diagram a number of related interactions that would require, for example, multiple communication diagrams. Another advantage of the sequence diagram is its ability to represent the passage of time graphically. The order of the messages is very clear. A sequence diagram reads from top to bottom. Sequence diagrams can also include return arrows. Another feature that can be added to sequence diagrams is object activation, showing when the object is active. And here is the summary. Sequence diagrams have own strengths and weaknesses, and like other diagrams, complement other diagram types. For example, it can help with finding classes and associations relating to the use case that were not obvious at first. It's also possible to choose complexity. Some sequences can be shown as a single box with a short description for a more simpler diagram, or there is an option to visualize more complicated stuff such as loops in details when it is important. It also allows discussing the design on how the system or parts of the system work in concrete terms, leaving little room for misunderstanding and keeping the diagram clean of info that's not relevant. It also helps to coordinate between teams working on different components that are going to be interacting. Specifically, to agree in detail how the components are going to interface with each other. Thank you for your attention.